Hello everyone. Today I'll be talking about counting principles. It's a very important concept, and counting the total number of possibilities of something to happen. This particular these principles play a very important role. So I'll be talking about multiplication rule, permutations, and combinations. So these are the three things I'll be talking about here, and we begin with the multiplication rule itself. Okay, let's take one example. So there is a city A. So there is a city A. So probably you are right now in Delhi, and then the first you have to go to Jaipur, and from there, let us suppose you are traveling to third city called Jammu, and you just want to go to Delhi to Jaipur, and there are three possible roads, three possible highways you can take, and these highways are numbered as highway number 1, highway number 2, highway number 3, and from Jaipur to Jammu you can actually travel through two different highways named as highway number 4 and highway number 5. So if I look into this particular problem, then from and your objective is actually traveling from Delhi to Jammu. So if I look into this particular problem, so there are three possible highways by which you can travel from Delhi to Jaipur, and two possible from Jaipur to Jammu. So total possible ways you can travel from Delhi to Jammu can be given by 3 times 2. That means 6 possible ways, and you can definitely list them down. The first route you can take is 1 and 4. The second route you can take is 1 and 5. Third route you can take is 2 and 4. The fourth route you can take is 2 and 5, and the next route you can take is 3 and 4, and the next route you can take is from 3 to 3 and 5. So these are 6 possible routes you can take. So where we are leading from this entire concept. So if there is a bigger work which can be broken down into several parts, so from A, and then from B, and then C, and then D, and then so on, and probably uh, there is Y, and there is another particular way Z. So any particular work can be broken out down into several pieces, and from A to B you can finish this work in two possible ways. Or I'm just going to make a general notation. So let us suppose I will say X one different ways. From B to C you can finish it up in X two different ways. From C to D you can finish it up in X three different ways, and so on. And this is exactly, there could be a possibility that you can finish it in xn different ways. So if I see this entire notation, then from A to Z, if you want to finish this work, that can possibly be finished by x1 times x2 times x3, and so on, xn possible ways. So this is the multiplication principle, whereas a bigger task can be broken down into smaller work, pieces of work, and then later on you can decide that how many ways things can finish up. Let us move to another important concept of factorial notation, which is going to play a vital role in permutation and combination. So what is a factorial notation? So you have got positive integers, and if there is a positive integer called let's say n, and you just want to write this will be called as n factorial. So n is a positive integer and it has been associated with a factorial notation. Then let me just rewrite it, clean it a little bit. So I'll just clean it up once again and I'll write it one more time. Okay. So I'm saying there is a positive integer called n, and there is a factorial sign associated to it. Another way to write factorial n is something like this, and it will be read as factorial on n or n factorial. So you can simply write it down like n times n minus 1 and n minus 2. So I'm discretely reducing n by 1 every single time and closing it at 1. So let's use this thing, and let's start with 0 factorial, which is always equal to 1. It's a positive integer. So 1 factorial is always equal to 1. Let's say how you're going to write 2 factorial. Interesting. It's 2 times 1. So n times n minus 1. Drop 2 by 1. And that's it. 3 factorial. I can simply write it 3 times 2 times 1. You've got something called 4 factorial. You can simply write it 4 times 3 times 2 times 1. Interestingly, there is 3 times 2 times 1 is 3 factorial. So this can be replaced by 3 factorial. That means I can conveniently write it as 4 times 3 factorial. You've got something. So I'm taking a bigger one. Let's say there is a 10 factorial. So you can simply write it 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1. You can also write it as 10 times 9 factorial. You can also write it as 10 times 9 times 8 factorial. You can also write it as 10 times 9 times 8 times 7 factorial. You can also write it as 10 times 9 times 8 times 7 times 6 factorial. Stopping the factorial in between somewhere becomes really, really handy when you are solving some problems in which numerator and denominator, both places, the factorial is appearing. Now let's move to our main part, that is, what do you understand by permutation? So here what exactly is happening? There are n positive integers and there are another positive integer which is r, and the property is that r is always less than equal to n, and I have to make r arrangements out of n because n is a bigger part. So n is a bigger part, and r could be either equal or less than n. So I don't know, how do you represent r? So r could be anything. R could be this smaller part, r could be this bigger part, r could be this entire n, or it can be equal to n. So this is something r is about. So this is r I'm representing certain r's, and this bigger part is n. So maximum value r can take is it can actually be equal to n. So I want to make r arrangements, r selections out of n, and notice the important thing here is if order matters. This is the key highlight of permutation, the order matters. In that case, these arrangements can be given by npr is equal to n factorial divided by n minus r factorial. That is how the permutations can be computed in order matters. Order matters means what? I'll tell you one simple example of what do I mean by the order matters. So if I have, let's say, two positive integers, 3 and 4, and written in this order, and I'm saying this is representing location of a point on xy plane. What do I mean by is, if you see, this is x, this is y, of course, this is 0, and 3 by 4 is something like 3 points here. I've got, let's say, 4 points here, and this particular point here is 3, 4. Now, if I reverse this order, that means I'm writing a different color. So if I'm writing, let's say, 4, 3, the only thing I've done is I've changed the order. Now it is different because 4 is somewhere here, and probably 3 is somewhere here, and this is a new point, 4, 3. So this ordered pair is representing a point in the plane, and the order matters. That means what is coming first and what is coming later. So these kind of problems are called as problems of permutation. Let's understand some examples and let us solve some particular problems. So I have first problem like 6 please 4. Just so that you can recall the formula, I'm rewriting it, n factorial upon n minus r factorial, of course. And here I've got n is equal to 6, r is equal to 4. then 6p4 would be equal to 6 factorial upon 6 minus 4 factorial, and that is 6 factorial divided by 2 factorial, and simply you can write it 6 times 5 times 4 times 3 times 2 factorial divided by 2 factorial, and I can just cancel it, and the remaining thing the calculation gives me 360. So there are 360 possible arrangements of 4 things out of 6 can be made. Understand another problem, that is, understand this another problem where I've got let's say how many ways 5 passengers can be arranged into 16 vacant seats. So I have 16 vacant seats, I've got 5 passengers. Now the problem becomes very, very simple. I'm going to go like 16p5, and that is going to give me 16 factorial divided by 16 minus 5 factorial. So that is 16 factorial divided by 11 factorial, and you can simply solve it. 16 times 15 times 14 times 13 times 12 times 11 factorial divided by 11 factorial, and if you solve it, then 5 2 4 1 6 0 are the total possible arrangements that can be made out of or for these 5 passengers on those 16 vacancies. So this is all I wanted to talk in this video. In next videos I'll be talking about little more advanced concepts of permutation.